Taking an app from a single server to a global, highly available network is one of the most expensive transitions a tech team can make. The actual compute power, the servers and the storage, is relatively cheap. What drains your budget is the engineering hours required to securely connect all those distant pieces together. In a traditional cloud setup, scaling means manually wiring up separate relational databases, compute instances, and custom routing logic for every new region you enter. You end up managing VPC peering, writing custom disaster recovery scripts, and building edge middleware just to keep the system talking to itself. Xuda approaches this differently. Instead of offering a massive menu of piecemeal cloud services, they provide a single, standardized data center building block. That unified block handles the hosting, the database, and the networking all at once, wiping out the need for that custom checklist. This diagram shows a Xuda building block. Every data center pairs a VPS host directly with a CouchDB database inside a single network boundary. Web apps, APIs, and workers all attach to this unit, communicating over a private, firewall-governed network, keeping traffic off the public internet. Achieving this clean operational surface requires a concession. Your team has to let go of fragmented database mixes and commit entirely to CouchDB. By forcing that strict architectural constraint, Xuda eliminates the custom networking and security configurations you'd normally have to build from scratch. That standardized block works well for a single location, but the real test is how it handles a global user base. This flowchart shows two separate regional Xuda data centers. To link them, Xuda uses a continuous CouchDB replicator. Data flows in both directions automatically for a multi-region setup. Built-in balancers route users to the nearest data center, while selective filtering ensures regions only share necessary global data. This exact same replication technology also doubles as your disaster recovery mechanism, replacing legacy snapshot tools. You can also branch a one-way mirrored data feed from your production node directly into an isolated staging data center. Enterprise-grade disaster recovery and localized QA testing are no longer massive DevOps projects. They are simple configuration changes on the dashboard. These scaling challenges get even harder for physical environments like retail stores, medical clinics, or automated factories that require zero-latency local compute. Xuda's lightweight data center model isn't restricted to managed cloud hosting. You can deploy it directly onto your own corporate servers or bare metal edge hardware. This diagram shows physical hardware integrating into the network. Cloud nodes extend to a Raspberry Pi edge node next to your workload. Data flows seamlessly between local devices and the cloud, utilizing the exact same replication topology, scheduled backups, and tag-based firewalls. This native hybrid setup solves major compliance and local-first requirements, as long as you are willing to restrict your hardware footprint to the operating systems supported by the Xuda ecosystem. The decision to adopt Xuda comes down to a very clear exchange. You are trading low-level database flexibility for operational velocity. This quadrant chart maps out where the platform makes the most strategic sense. The vertical axis tracks the effort to deploy, and the horizontal axis measures the need for customization. The bottom left quadrant, low effort, low customization, is the definitive buy zone for Xuda. Growth phase CTOs belong here. If you need rapid multi-region expansion but don't want to hire a dedicated networking staff, the standardized blocks fit perfectly. Distributed edge and IoT use cases also land in the buy zone, gaining immediate value from native hybrid topologies and physical stores and factories. Enterprise compliance teams fit here as well, since built-in gated SSH and reversible restores offer predictable governance out of the box. Conversely, the top right quadrant, representing a high need for customization, is a strict pass zone. If you rely on heavily entrenched, deeply nested relational queries, those legacy SQL systems cannot easily migrate to a CouchDB building block. Hyper-customizers should also pass. Teams requiring granular packet control or bespoke load balancing logic will find Xuda's opinionated simplicity restrictive. Look closely at your own roadmap. Is your next major growth hurdle constrained by a lack of raw compute power or DevOps bandwidth? If DevOps bottlenecks are holding you back and you're ready to evaluate the migration effort, check the video description for Insight Anchor's deep dive checklist.